All right, here's our video today. Galileo's Principle of Equivalence. Fancy title. Was actually given the name, the Principle of Equivalence. Galileo did not call it that, right? Einstein called it this much later in the 20th century. So Galileo, now he died in 1642. So it's also called the Principle of Equivalence of Inertial Gravitational Mass. It's a handful there. But it's actually simple. So it's a lot more simple than it sounds. So basically, and when Galileo did this, people did not believe him. So what he did, it's just saying that if you take two objects, let's draw it. Let's take those two objects. We have the Leaning Tower of Pisa here in Italy. And that's what he used. Galileo was throwing objects off this tower, and he was proving that Aristotle, who lived some 2,000 years before him, was wrong. But everyone accepted Aristotle's um, ideas, and so you couldn't refute Aristotle. If you did, people thought you were crazy, and they didn't believe Galileo even when he showed them. They still didn't want to believe it. So, what should we use? Let's use yellow. So let's say we have these two objects, and one object was, let's say, 100 pounds, and we have another object over here, and let's say it's just whatever, 5 pounds. So these two objects, and let's say the ground is here, right? Or we could have used the ground with the Leaning Tower of Pisa. But if we drop these two objects from the same height, they will fall at the same time. They will land on the ground at the same time. And Galileo said that would happen. But Aristotle and people during Galileo's time said no, the heavier object would fall first. But Galileo proved them wrong. And they still wouldn't believe. So if just take any objects, take any object, and one's heavier than the other, and drop them, you'll see that they will land at the same time. And of course, there is also air resistance to take into consideration. So if there's any air resistance, like for example, a piece of paper, a piece of paper will float up and down because of the drag, because of air resistance. So in a vacuum, two objects will land at the same time. And of course, if the object's lighter than air, it's not going to fall at all, like a helium balloon. So here it is. Let's pretend Galileo's up here at the. Let's get our pen going here. We'll use green this time. So we'll pretend Galileo is doing something. Here we go. There it is. Finally get the pen to work. So here's an object, and here's another object. And that's 20 pounds, and let's say that's 1 pound. And for some reason, we know, according to the principle of equivalence, they will land at the same time on the ground, hopefully not hitting that person there. But if there's, again, drag, there's any kind of air resistance, some kind of tornado just showed up, then perhaps, the lighter object could be delayed. But in general, they will land at the same time. So what he was trying to say is this has nothing to do with your mass. It's all about gravity. So let's write that down. We'll use white, see if it comes out. So basically what Galileo found out is mass, and maybe we should change the color. Use red. There we go. Mass has no effect. Has no effect. Mass has no effect. It's all about gravity. So mass has no effect, or you can say mass, the mass of the objects, do not affect gravity. So, and on Earth, the gravitational rate, the rate in which gravity pulls you, is 9.81 meters per second squared. So it's all about gravity. I'm going to do a little equation of that. By the way, the equation I'm going to put through here was not, Galileo did not use this equation. And actually, no one knows who invented this equation. Everyone thinks Newton did, and perhaps he did. But the equation is this. Let's say we had a tower, or we had a building, and we wanted to know or prove that mass doesn't have any effect. We can take an object and throw it off. Actually, we don't want to throw it off. We just want to drop it. Because if we throw it, we're adding force to it. And if we add force, that could affect it. This is if we don't add force, we just drop the object. So if we drop this object, we could find the height of the building by this equation. Says half g times t squared. And so as you know, if you can look at this equation here, there's mass is not involved, right? So all we have to do is we need the time, and we can find h. We can find the height of the building. So for example, let's do that. Let's say we have h, and we got to do half g. So we know this is g right here. That's g. That's lowercase g is the acceleration due to gravity on Earth. All right. On the moon, by the way, it would be different. On the moon, the acceleration due to gravity is 1.6 meters per second squared. Remember, your mass is the same no matter where you go, but your weight is different on different planets. You'll weigh much less on the moon because the gravity is weaker. Let's get back to this equation. So half of 9.81 will be roughly 4.9. Well, we can just say 4.905. And you're going to times it by whatever we say it took for this thing to fall down. Let's say it took 3 seconds. Well, t will be 3. 3 squared is 9. And then just do that. Just do it. And you'll get, remember, this is in meters, so you'll get roughly 44 meters. Roughly 44 meters. 44.145, right? And in feet, by the way, that would be like about 144 feet. So you can see we can find the height of the building, how long it took. It took 3 seconds for the ball to land, and we didn't use mass. All right, and we'll go back to the Leaning Tower of Pisa. So that's the video today. Again, we proved, well, we didn't prove it, Galileo proved that no matter what the weight is, the objects will land at the same time, unless, of course, there is drag or wind resistance. All right, that's our video today.